Hello, welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement of creating these kinds of technical videos in public domain. I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty my God for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers for continuous watching of my videos. Today's topic of interest is hydraulic turbines. We were discussed in detail about the hydraulic turbines in previous lecture. If you are not seen that lecture, please see that. I will put the link of the previous lecture in the description box so that you can understand better in this video. So here we are going to discuss what is turbine, what are the different types of turbine, and we are going to compare the impulse and reaction turbines, and with the parameters we are going to compare all the Pelton, Francis and Kaplan turbines, and we are going to discuss some of the detailed important relations between the parameters in the turbine. So please don't miss this video. I request you all to continuously watch the video, then only you get a good clarity about this hydraulic turbines. First of all, I would like to clear about this thing. The hydraulic turbine, which converts hydraulic energy into mechanical energy. These hydraulic turbines are generally in hydroelectric power stations. The layout of the hydroelectric power stations are a bit like this. The hydroelectric power station consists of a dam and a dam with a reservoir and inlet, control gate, penstock, turbine, draft tube. From the turbine, the rotational energy is converted into a mechanical energy. The rotational energy in the form of mechanical energy is converted into electrical energy by means of a generator, and it is being transformed. It is being transformed from generator to the main grid line through the transformer, powerhouse and the power lines. So one thing you have to understand that the hydraulic turbines, which converts the hydraulic energy into mechanical energy, the hydraulic energy is in the form of both pressure as well as the velocity. If I need to classify the turbines in terms of the pressure and velocity, the energy available in the inlet of the turbine, there is a two types. One is impulse and reaction, where the impulse turbine, so this is an impulse turbine, so which have a pure velocity dependent turbine, that is kinetic energy is being converted into a rotational energy, that is mechanical energy. And in these two turbines, these are all reaction turbines. So here both kinetic energy and pressure energy is used to run the turbine. So here, so this is an impulse turbine. This is an impulse turbine. I can say it is a Pelton turbine. Okay, and it is a tangential flow turbines. The flow is tangential to the rotor, whereas in these two reaction turbines is either a mixed flow or axial flow or a radial flow turbines. With the flow, it is being varied, and this is used for high head, and these are all used for medium and low head, which I am going to discuss in detail with a table column for your betterment of understanding. So with these inputs, I would like to start my lecture and in my style, I'm having my own notes. So the hydraulic turbines, the hydraulic energy is converted into mechanical energy. We have two types of turbines. One is an impulse turbine, that is only kinetic energy is being used, and it run by an impulsive force. It is run by an impulsive force. This impulsive force is nothing but moment of momentum, that is derived from Newton's second law. So Newton's second law. So which is the impulse is the force into time, and the example for the impulse turbine is a Pelton wheel turbine or impulse turbo turbines, like that, where the reaction turbines uses both pressure energy as well as the kinetic energy, and the examples like Kaplan turbine, Propeller turbine, Francis turbines are the examples of reaction turbine. Here I would like to give detailed comparison about the impulse and reaction turbine. In impulse turbine, nozzle is there and moving blade is there. Moving blade is in the form of hemispherical shape, that is like a spoon in structure, which have a capacity to handle the high pressure, high velocity. And whereas in the reaction turbines, it consists of a fixed and moving blades. In impulse turbine, pressure drop across the nozzle is occur. Pressure drop is occur at the nozzle, whereas both the sides of the blade which is equal to atmospheric pressure. Whereas in the reaction turbine, the pressure drop in both fixed and moving blade is there. And impulse turbine, the partial admission is possible, whereas reaction turbine, partial admission is not possible. In impulse turbine, there is no draft tube. In reaction turbine, draft tube is used, since this is having a kinetic energy. So we have to convert all the kinetic energies into pressure energy. That is why the draft tube is being used. So draft tube converts the kinetic energy into the pressure energy. So here one thing you have to notice, that since there is a pressure drop, between the fixed and moving blades, there is a chance of cavitation. In the Kaplan and the Francis turbines, that is in the reaction turbines, which I have given in detail. The points to remember, that the cavitation is by vapor pressure. What is meant by vapor pressure? How the cavitation occurs? Since there is a pressure, take this as a blade, there is a pressure drop occurs here and here. In anywhere between the pressure drop, since due to the pressure drop, the liquid water is converted into a liquid vapor, and it is sedimented in the turbine blade. Better, we can say at the exit of the turbine blade, it is accumulated. So the area which accumulated by the water vapor is a loss. So that is why we are called as an cavitation. So this cavitation will tend to reduce the efficiency, and prolonged time it breaks the blade, even it can break the blade. That is why the cavitation is an important phenomena in both turbine and pump. In centrifugal pump and the reaction turbines. In the pump, the cavitation is generally entered at the entry. In the turbine, it is at the exit. We can easily remember that the turbine, last letter is an E, that is exit. Pump, so there is no E. So if we notice, the turbine is for exit, the pump is for inlet or entry. We can easily remember this. So number of nozzle used in Pelton wheel without interference is equal to 6, and the atmospheric pressure is less than vapor pressure, that is 2.6 meter of water. That is why the bubbles are formed with the high noise and pitting effect. After cavitation, the vapor bubble is formed. After that, it will produce noise. It will burst and produce noise, and it pitting in the blades. That is why the blades are getting damaged. So next, we are going to discuss about the three types of the Pelton turbine, and we are going to classify. We are going to compare with the parameters. I have said the first is a Pelton, second is a Francis, third is a Kaplan. This is the parameters which I have discussed, so that you have easily get the difference between all the three turbines. Head in the Pelton turbine is an high head. Francis, it is a medium head. Kaplan, it is a low head. The Francis I have took is inward radial flow turbines. Inward radial flow turbine. In the second parameter power, the Pelton produce high power, Francis produce medium, and Kaplan produce low power. The discharge, Pelton is low, Francis is medium, and Kaplan is high. The speed, Pelton is low and Francis is medium, Kaplan is high. Flow, types of flow, Pelton is a tangential flow, and Francis is a radial flow, and Kaplan is an axial flow. And the types of the turbine, it is an impulse turbine, it is a reaction turbine, and so this is the Pelton, this is the Francis, this is the Kaplan. So Kaplan and Francis are reaction turbines, the Pelton is an impulse turbine. In draft tube, there is no draft tube in Pelton wheel, whereas there is a draft tube present in both the Francis and the Kaplan turbines. So here one thing you have to understand, that in reaction turbines there is a draft tube, whereas in impulse turbine there is no draft tube. The specific speed of the Pelton turbine is 10 to 35, where the Francis is 60 to 300, and the Kaplan is 300 to 1000. Heads, above 250 meter head only Pelton is used. So Francis is used between 60 to 250, and Kaplan turbine we can use below 60. Where the speed ratio for the Pelton is 0.46 to 5, for the Francis is 0.43 to 0.65, and the Kaplan it is greater, speed ratio is greater than 0.7. In the number of blades used, the Pelton is having a formula, so minimum number of blades is 18. So minimum number of blades should be 18. So it is having a formula that 15 plus capital D by small d, where capital D is the bucket diameter and small d is the jet diameter. And for the Francis turbine, the number of blades is 8 to 12, whereas Kaplan turbine it is from 4 to 8. So I hope you have understand both the three types of the turbines in detail. So hereafter we are going to discuss the relationship among these turbines. The relationship is plotted in three types of a graph. One is main characteristic graph, operating characteristic graph, and Muschel graph. In main characteristic graph, head is kept constant. In operating characteristic graph, that is OC curve, the speed is kept constant. In Muschel curve, the efficiency is get constant. Here the relationship are derived from the unit speed, unit quantities and specific speed. Unit quantities means unit speed, unit discharge, and unit power. and we have a relationship for the specific speed also. First you have to know what is the power relationship. The power is directly proportional to power 3 times of the speed and power 5 times of the diameter and power 3 by 2 times of the head, h power 3 by 2. So this is the relationship among the power and speed and head, sorry, and diameter and the head. So this you have to understand. If the diameter of the wheel is increased by 2 times, the power is increased by 32 times. So that you have to understand. If the speed is increased by 2 times, the power is increased by 8 times. That you have to notice this. So this is the important relation. Please make a note. And the discharge, according to the discharge is directly proportional to speed, and it is again directly proportional to third power of the diameter, and it is directly proportional to square root of h. This we have to understand that. And the head relationship, head is directly proportional to diameter square and directly proportional to speed square. And we know that the power is directly proportional to h power 3 by 2 and speed is directly proportional to h power 1 by 2 and the discharge is also proportional to h power 1 by 2. This you have to understand. So where it is coming, it came from this unit quantities, that is unit unit discharge, unit speed and unit power, where these unit quantities are indicated the size and shape of the turbine. Size and shape of the turbine, unit quantities will indicate the size and shape of the turbine, or where specific speed which will indicate the capacity of the turbine. These thing you have to understand very much. So these terms are very needed term, much needed term in pump as well as the turbine. So here the discharge is unit discharge, which is equal to discharge divided by root h. That is why here the q and h, the relationship, q and h relationship, we can understand q is directly proportional to root h. That is why q is directly proportional to h power minus 1 by 2, h power 1 by 2. And similarly the unit speed nu is equal to n divided by root h, where n is directly proportional to root h, where n is directly proportional to h power 1 by 2. And similarly unit power is equal to p by h root h, or we can say p divided by h power 3 by 2. Say we can say p is directly proportional to h power 3 by 2. So that much simple. So and we know that power is equal to rho g q h, where this rho g h is equal to pressure. Therefore power is equal to pressure into discharge, where we can say the power, since the density and gravity is constant, the power is directly proportional to this q, discharge and head. We know that q is equal to area into velocity as per continuity equation. Therefore p is directly proportional to a v into h. We know that area is equal to pi by 4 d square, and again this is a constant. Therefore capital D square. Therefore, P is directly proportional to D square, and V, which is nothing but root of 2GH, where H is the root H. That is why P is directly proportional to H power 3 by 2. And similarly, there is another relationship where velocity is equal to pi d n by 60 is also there. 60 is also there. Therefore, area is already d square. Therefore, this is d cube and n. So, and again h we can easily indicate in d square into n. Therefore, power is directly proportional to d power 5 into n cube. So this is how the relationships are being maintained. So next we are going to discuss what is the difference between Kaplan and propeller turbine. It is very simple. Kaplan turbine, it is an adjustable blade turbine. Both are reaction turbines, both are axial flow reaction turbines. Whereas Kaplan is having an adjustable blades, whereas propeller is having non-adjustable blades. Remaining same as a Kaplan turbine. For propeller turbine, remaining things are same. It is an axial flow. The efficiency is 60 to 140 percentage of the efficiency we can get in Kaplan turbine and propeller turbine. Whereas in the Pelton turbine, we have a condition that condition of maximum efficiency, the jet speed is equal to 2 times of the bucket speed, whereas the V is equal to 2 times of U. So V, that is root of 2GH, is equal to 2 times of U pi dN by 60. Then only the efficiency will get maximum. In the tubular turbine is a bulb turbine, that is, we can say tube and bulb. You can remember by means of this. Next, as we discussed earlier, how the cavitation is an important phenomena, like that the water hammer is another important phenomena in hydroelectric power stations. When, if we are in need of a sudden closure of valve, there is a sudden pressure difference occur, where it tend to burst the penstock. Since the sudden increase in pressure, it will burst the penstock. That is why in the penstock is fitted with the surge tank. The surge tank will reduce the water hammer effect. So water hammer is occur due to sudden closure of valve. So it is valve. So sudden closure of valve, it will create a bursting effect. The pressure is being increased. In order to recover this problem, we are using surge tanks. Surge tank will help the penstock in safest manner, whereas water hammer tend to burst the penstock. So if it bursts, the high amount of the potential energy is being delivered this small crack, so it may cause anything. Next is the specific speed. As I said earlier, it indicates the quantity operating characteristics of a turbine. So generally the turbine and pump we have to compare in terms of the specific speed. If I say turbine, the specific speed of a turbine is, since it is a power producing device, N root P divided by H power 5 by 4, where pump, it is a work getting device, so it produces discharge, therefore N root Q divided by H power 3 by 4. H power 3 by 4. So if you can see, so these terms are getting constant. So whereas this is 5 by 4, this is 3 by 4, where turbine will produce the power, where the pump produces discharge. So that is the simple thing. So here the dimensions of both the things are bit similar. Dimensions of the specific speed of the pump and turbine is root m and L power minus 1 by 4 and T power minus 5 by 2 for both are same. So with this I would like to stop today's session about the hydraulic turbines. I hope I have given an enough knowledge about the hydraulic turbines. If you can see my previous lecture, you can understand better about the hydraulic turbines. So with this, I'm going to close the today's session. If you like my video, please like and share my video. If you have any doubts, please let me know in the comment section and I will put another video for clarifying your doubts. Okay friends, so with this I conclude today's lecture and thank you and bye bye from Santhosh. Thank you all.